All right, so hello and welcome. Here we are, another question. Give it a few seconds, make sure the stream is working and the audio is working. Let's see. The stream is working and the, very good, working. Okay, deep breath. So this next question is number 1117 on LeetCode, building H2O. Let's get into it now. All right, just take a moment. There are two kinds of threads, oxygen and hydrogen. Your goal is to group these threads to form water molecules. There is a barrier where each thread has to wait until a complete molecule can be formed. Hydrogen and oxygen threads will be given release hydrogen and release oxygen methods respectively, which will allow them to pass the barrier. These threads should pass the barrier in groups of 3, and they must immediately bond with each other to form a water molecule. You must guarantee that all the threads from one molecule bond before any other threads from the next molecule do. In other words, if an oxygen thread arrives at the barrier when no hydrogen threads are present, it must wait for 2 hydrogen threads. If a hydrogen thread arrives at the barrier when no other threads are present, it must wait for an oxygen thread and another hydrogen thread. We do not have to worry about matching the threads up explicitly. The threads do not necessarily know which other threads they are paired up with. The key is that threads pass the barriers in complete sets. Thus, if we examine the sequence of threads that bind and divide them into groups of 3, each group should contain 1 oxygen and 2 hydrogen threads. Write synchronization code for our oxygen and hydrogen molecules that enforces these constraints. Okay, so this is similar to, maybe I would use a semaphore for this. I was trying to figure out why I would use a semaphore. Starting to figure out maybe why. Water is HOH, HHO. HOH and OHH are also valid answers. Water is OOHH, HH, HHO, HHO. Any of these are all valid answers. Okay, so 3 times n is water length. 1 is less than or equal to n, so n is between 1 and 20 inclusive. Water of I is either H or O. There will be exactly 2 times n H in water. There will be exactly n O in water. Okay. Oh, my body. So we want 20 n molecules, and the water length is going to be 3n. Water of I is either H or O. There will be exactly 2n H in water. There will be exactly n O in water. Again, relatively low submission rate, relatively high acceptance rate. Okay, they explain a little bit more how they want this done. Release hydrogen outputs H, do not change or remove this line. Release oxygen outputs O, do not change or remove this line. Excuse me. I don't really know. It's funny, I've seen this question over the years. I've seen it so many times. Just scrolling through all the different questions, the other question set. And I always looked at it and I was like, oh, this is probably not going to be too hard of a question. And now I'm looking at it like I have no idea what I'm looking at. So, oh, okay, I guess it doesn't matter. I guess it just starts a thread that releases oxygen and a thread that releases hydrogen. And I've got to wait until I get 1 oxygen and 2 hydrogens. Okay, I think I understand. I kind of want to use a barrier. So we get 1 oxygen and 2 hydrogens. 1 oxygen and 2 hydrogens. Okay. So I'm going to use synchronization primitives to get this to work. And interesting. So I don't know if these are functions are called like in a loop. I'm assuming these are called in a loop. I don't really know. I want to say I could use a barrier. That's kind of what I'm thinking. Thinking probably I could use a barrier or a mutex. A few mutexes probably are fine here too. Even a semaphore maybe could work. Let's see. mutex, semaphore, barrier, latch, even maybe a latch. Kind of want to use a barrier. I think how it would work with a barrier is I can synchronize one hydrogen and one oxygen. Well, I mean, if I just added another line here, if I just added another line, I think it would be too much output if I did that way. Yeah, it's too much output if I do it that way. Oh, I see. So it doesn't call the hydrogen. It calls the hydrogen it calls the hydrogen twice as many times anyway. Okay. I'm wondering if I should use a barrier. I don't know. It seems like I could try it, but I don't think it works the way I'd like it to. I don't know about this. I don't think this makes sense. What I'm trying to do here. I have to be a little more clever than this. I'm thinking maybe I could use mutexes or semaphores. Maybe even a semaphore might work. Yeah, it doesn't really do. It's interesting I have to include that. That's kind of weird. Yeah, I think maybe I do need to use a semaphore here. Maybe that's what the point of this is. Oh, TLE. Well, that's awkward. Gee. Ooh. Okay. I think it TLEs because it's not, n isn't mod 2, yeah, n isn't divisible by 2. This doesn't really do anything. Doesn't really do anything. I don't think so. How does this work? So I want to synchronize 3 threads. I'm not sure I fully understand. I want these 2 hydrogen threads to synchronize with each other and 1 oxygen thread to synchronize. I don't want another oxygen execution to occur until I've got 2 hydrogens and 1 oxygen. I mean, I could do conditions maybe. Maybe conditional variables work. CVs. I think a barrier is maybe not quite what I want. Yeah, because I want to specify which conditions. So give integer hydrogen H and O, hydrogen, oxygen. And then we could have condition variable CV. And we can say release hydrogen, increments hydrogen. We have CV.wait. Excuse me, we have a lock as well. Unique lock mutex. I think I just unique lock. Yeah, it's fine. Maybe it's just M altogether. I don't know if it's M1, M2, I'm not sure. Okay, so we've got this lock, obtain the lock, release hydrogen, increment hydrogen, and then we're going to CV wait lock with a function, which I guess we'll just start with true. And then once hydrogen has been released, then we want to release 2 hydrogens. So this is very similar to also want to release oxygen this way. Okay. Oxygen. So maybe I want 2 locks. Not sure exactly. I'm actually not sure. Because there's gonna be 3 threads to be concerned about, and I'm not gonna output any more oxygen until I have all the hydrogen that I need. I'm not gonna output any more hydrogen until I have all the oxygen that I need. That's the idea. And I'm only gonna print one or the other, right? So 1, 2 hydrogen. Yeah. So let's do 2 mutexes to see what that looks like. I mean, maybe 2 is fine. We'll come back to that. Maybe 2 is fine. We'll try it with 2 and then see what happens. So hydrogen, so when there's enough oxygen is 1, then we can continue. We're gonna notify. Oxygen is 1, notify, and then it'll repeat again to print out another hydrogen. Yeah, it'll hold until another hydrogen is printed, and then it'll print another hydrogen, or hold until an oxygen. If hydrogen is greater than or equal to 2, we want to reset that to 0. And I'm wondering if these should be atomic. That also is another question. Maybe, I don't know if that actually matters. This is going to release the lock on this thread and wait. I don't know if that actually matters. And then once the lock will be reacquired and then dropped here after the unique thread, lock goes out of scope. Maybe something over here too. It's a similar kind of a thing. Now, hydrogen is greater than or equal to 2. We're going to say notify 1. Notify the other thread that's waiting. And I don't know if this really makes sense what I'm doing here. Not sure. So hydrogen is 2. That's when we can keep going. Same thing, acquire the other lock, release oxygen, drop the lock and wait, and then we'll pick up the lock again and then drop it again here. And hydrogen is 2 if oxygen is greater than or equal to 1. Right, then we set the oxygen back to 0. And we notify. Yeah, something like this. Something along these lines, I don't really know. This is totally correct. I have to think about it for a while. But something like this I think works. Presumably. Oh. You could say N hydrogen, or NH and NO. That might be better, NH and NO. It's better. Oh, it's TLE. Uh-oh. It got stuck. Oh no. Okay, let's try again. So I don't know. Something strange is going on here. Well, it's not that strange. It's just yeah. I don't know. I don't know. I think they both lock, right? But this one, I don't know, just put CVs all over the place. Just notify everywhere. Keep it simple. Just have notifications all over the place. Is it still TLE? That would be disappointing. It does. Oh no. Release hydrogen, release oxygen, notify. I think it should be notify all. I'm just gonna notify all. Whatever. Just keep it simple. All these threads that are waiting. I don't know. I don't know. I don't know what's happening here. I don't know. This is like, what is going on? I don't really know why it's not working. That's what I'm confused about. So let's just start with cout thread called created, hydrogen thread created. So I don't really know how these are being called in the first place. It's a little bit confusing. I think they're all being called at once or something, or maybe it's in sequence. I don't know. I don't know what's going on. Let's start with that. Let's just see how many threads are created. So hydrogen thread created, hydrogen thread created. Oxygen thread created, okay. Also, it's a bad habit to do this. So there's no particular order, I think, that these threads are created. Let's actually make this larger. Yeah, this is interesting. I don't know. I think it's just throwing a whole bunch of threads down there. Yeah, 1, 2, 3, 1, 2, 3. I think they're all being created at random times, more or less, the threads. It's just all being generated at once. Yeah, so it's... Okay, hydrogen, oxygen, hydrogen, 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 oxygen, hydrogen, hydrogen, oxygen. 1, 1, 1, 2, 3, 1, 1, 1, 1. Yeah, I think they're just, like, it's just a sequence of threads that's being created. Like they're all just being dumped. They all get their own thread. Okay, that's really confusing. So, okay. Excuse me. So, I mean, I could just have a synchronization point where all the threads will wait on a condition variable. I can't specify which. Oh man, this is a tough one, huh? Gee. Excuse me. Gee. Oh man. Alright. I'm gonna lay down for a minute. Sit down, lay down. Gonna go ahead and lay down for a minute. I don't know. So basically, what I'm understanding is there's just like a whole handful of threads that are created, right? Excuse me, like I just create 9 threads, just boom, 1, 2, 3, 4, 5, 6, 7, 8, 9, just straight out of the gate, 9 threads, and 6 of them will print a hydrogen and 3 of them will print an oxygen. Okay, and somehow I gotta get 2 hydrogens and an oxygen to print before the next 2 hydrogens and an oxygen. Make sure it's a sequence of that sort. Oh, of course. I mean, sure. Excuse me. Why not? What? How am I supposed to do that? What? What? Okay. I mean, yeah. Sure. I have no idea. It's a good question. Excuse me. It's a good question. Test your concurrency understanding and knowledge. Yeah, concurrency is pretty challenging. It seems pretty challenging. So, I don't know. Problem is if I put a mutex, let's say I put a mutex in there, right? And okay, maybe I could put 2 mutexes for hydrogens and 1 mutex for an oxygen, right? What's going to happen is all the oxygen threads will hold until 1 oxygen is released, right? One oxygen thread gets the oxygen right to print an oxygen, and all the other threads can't print while that one's printing. And then for the hydrogen, 2 threads. Well, I guess I could use semaphores. Yeah, I could use semaphores. That works. I could use just two threads for hydrogen are able to print, and then all the other ones get locked. Problem with that though is like, while it's true I'll be printing 2 hydrogens at a time and 1 oxygen at a time using the semaphore and a mutex. The problem is I think I still need a barrier to make sure they're grouped properly. A synchronization point. Yeah, that works. Actually, that's fine. Okay. I'll just use a semaphore, 2 semaphores and a barrier. Boom, done. Done. Got it. Easy peasy, no problem. Oh, got it. Yeah, that's fine. I don't know, there's probably a better solution than that, but that's good enough for me. That works for me, man. That works for me. You ready for this? Are you ready for this? So they don't unlock, basically. Okay, forget condition variables. We're going to use... I probably could do with condition variables, although it's not obvious exactly how to do that. I think I got it. I think I got it. I don't use this too frequently. Counting semaphore. Excuse me, binary semaphore. What's a binary semaphore? Are these the same things? Oh, it's a alias. Okay. All right. Anyway, so we'll do counting semaphore and binary semaphore. Okay. So hydrogen is 2. This is 1, which is basically just a mutex, which is a binary semaphore. All right. So the idea is going to be, don't need this anymore. This was kind of a confusing mess. It wasn't right. Didn't really make a lot of sense. All of this, I think, goes. So what we're going to do is we're going to take our hydrogen semaphore and acquire twice acquire. And then once that's been acquired twice, we release. Right. Okay. And there's also the barrier, arrive and wait. Yeah, so 2 of these will acquire and 2 will arrive, release their hydrogen and arrive. 1 of these on the other side should acquire simultaneously. I don't think I need this anymore. I think I understand what's going on. On the other side, we're going to have the oxygen acquire. And similarly, d dot arrive and wait. It's only 1 of these. Okay. Something like this, I think, should do the trick. Now, it may not be totally correct, I suspect. Template. These max values too. Can this be a 2? It's kind of weird. Wait, what? What does that mean, least max value? Counting semaphore, oh, I should probably, yeah. Counting semaphore is a lightweight synchronization primitive that can control access to a shared resource. Unlike a mutex, counting semaphore allows more than one concurrent access to the same resource for least max value concurrent accessors. Program is ill-formed if the least max value is negative. Or at least max value concurrent accessors. At least 1, at least 2. Oh, okay, I guess it doesn't really matter. It could be 1, it could be 2. It's at least 1, at least 2. It's guaranteed. I think it's guaranteed at least, I don't know if that matters, actually. Right? Least max value could be anything. Cool. Go for it. I'm gonna go for it. Could be wrong. Oh, got it. Hey, sweet. I don't know if this is right. Let me submit it a few more times. Something about this is a little bit odd to me. I mean, it works, but it's a little bit strange. Actually, let's keep that open in case I want to use that later. It's relatively fast. The reason why I'm wondering if this is a correct solution is Like, I'm wondering if there's somehow there could be something goes wrong here. I don't think so. Hey, 100%, nice, fastest. 1, 2, 3, 4. We'll do one more. All right. So if you like the video, give it a like and subscribe for more if you want more. And thank you for watching. I'm going to restart the stream with a new problem. Yeah, sometimes it's faster than other times. My question here is, why does this work? Before I do that, let me just check and see why this works. So all the hydrogen threads and all the oxygen threads, 2 of the hydrogen acquire, all the other ones block. 2 of the oxygen acquire, all the other ones block. 1 acquires, other ones block. We release hydrogen, release oxygen, and the ones that are blocked are not going to reach the barrier. The ones that are not blocked will reach the barrier. They'll all synchronize, and then they'll also all release at the same time, which is going to cause the barrier to refresh, and the next 3 threads, as soon as this one releases, one is going to acquire. As soon as the other one releases, another one's going to acquire. Same thing, they're going to release hydrogen and wait at the barrier, and same thing, the oxygen is going to release and wait at the barrier. And it's guaranteed that you need all 3 to breach the barrier, because the barrier is of size 3. This will only provide 2, this only provides 1. And even if both of these finish at the same time and get here, you still have to wait for the hydrogen and vice versa. So it's guaranteed that you're always going to have to wait. Yeah, the barrier allows you to group by 3, and the hydrogen and oxygen allow you to prevent the semaphores allow you to prevent the other threads from printing. Yeah, really cool question. Good question. Okay, so it was correct. It was the right answer. Yeah, for some reason I wasn't sure. All right, I'm gonna go ahead and restart.